solutions. Infinite number of solutions. It means that you had the same line written differently. So you just solve for where does a line intersect with itself, and essentially you answer that question with everywhere that line exists.
What if it was like 0, 8?
0 equals 8?
Yeah.
That means they don't intersect. They're parallel.
So,
no solutions. No solutions, exactly. Okay, so what do you got? What number did you guys isolate as something you want to talk about? Nate, which number?
45.
Number 45. Nice. Okay, 45. We got 3x plus 4y equals -6, and 5x plus 3y is equal to 1. Got it. So did you have to use by elimination here?
Yeah.
Nice. Okay, we can do that. So by elimination, you're trying to line it up so that you can eliminate a certain pair. So do you want to go after the x's or y's, Nate? What do you want to go for?
I went after the x's.
You went after the x's, so you need to get opposite coefficients for the x's. What'd you multiply the top one by?
5.
Yeah, that's great. If you multiply by 5, what did you end up with?
15x
Yep.
plus 20y.
Mm-hmm. Nice. So if you want to get the opposite, what would you multiply the bottom one by, Calvin? Yeah, times -3. If you multiply by that -3, what do you end up with on the next line, Calvin?
-15x plus 30 minus
Mhm.
9y equals -6.
Correct. And if you add these two together, what do you end up with? Whoa, does the magic happen? Yeah, that goes away. So we get 11y is equal to -33. Divide both sides by?
11.
So y is equal to?
-3.
Is it a good sign when you end up with a nice number like that?
Yes.
It's generally a nice number. It's either your subconscious helping you or your subconscious doing something that gives you the wrong nice number. It's very rare to get a nice number like that and it not be at least partially correct. We're not quite done yet because what else do we need?
X.
X, exactly. Now, what are our choices for where to put this? Either one. Does it matter?
Yes.
Theoretically, we should get the same value irregardless. So let's do the first one. 3 times x plus 4 times -3 is equal to?
-6.
Nice. So 3x is equal to -6 plus 12. So 3x is equal to?
6.
X equals? 2. So if you want to properly write your answer, I'd like to see 2, 3. And when you have time, what should you do?
-2.
Oh, negative. Thank you. You should check. You should check. Absolutely. A common thing, or one reason elimination is easy for machines to do, is because the algorithm is really generally easy to describe. You pick either x or y, you look at the coefficients, and how can you always make it so that you end up with opposite coefficients? Multiply the upper one by the lower one. Multiply the lower one by the upper one, just negative. You can always do that. It'll always work. So it's generally pretty easy to program. That's why elimination. Machines like things that are easy to break down into small steps. That's all a computer is. Lots of small things being done quickly. Other questions from the homework? What do you got? Yeah.
81.
81. We are climbing the charts, huh? We are climbing the charts. Let's see if we're going to do this one. Awesome. 81. Oh, a graph one right there. Did you check this over with your partner? We didn't have time. Okay, well we'll wait until group work. Okay, well doubly kind of needed. Okay, we'll wait until we have more group time to go over this. Okay, I want you to check this over with someone else in your pair first. Substitution. You're supposed to use substitution. Now, what problem did you run into, and did you check this with somebody else?
Yeah,
And what? Oh, you got different answers?
I got different answers.
Ah, okay. So for substitution, what was that first word you needed to remember for substitution?
Isolate.
Isolate. So you have to pick a variable to isolate, x or y in the first or second. Which one do you want to pick? Okay, wait. That's what we're going to do once we've picked it. X in the... So yeah, so we want to isolate x in the second. If we multiply this by -1, you end up with -3 plus 2y equals x. Now, have we properly isolated x? Yes, we have isolated by doing the things you outlined. Now, where do I put that, Kelly? Yeah, you sub in for x in the upper one, wherever x is, and you end up with, oh, that was that second word, substitute. 5 times -3 plus 2y minus 4y is equal to 9. One word for what we have to do next to this. One word. What do we have to do? Distribute. Exactly. And we end up with negative 15 plus 10y minus 4y equals 9. Is that a single variable equation that we're really, really happy with?
No.
No, we're not? Did we make it? Is it wrong?
No. It's just not simple.
It's not totally simplified.
Yeah.
Correct. Plus 6y equals 9. So 6y is going to be equal to what? Negative or positive what? 9 plus 15? Can you do 9 plus 15, big guy? Can you do that? Can you do that yet? You didn't think you were going to get called on, did you? Yeah. What's y? What's y equal to?
4.
4. Does that help you out? Where do you plug that back? Oh, it's pretty repetitive, but once we get 1, what do? We keep going in. Nice, nice. Okay, please put everything away except the pencil. You're going to prove that you can do that. What? You said Z? Yeah, that's right, yeah. We're going to have things that look like this. 2x plus 3y minus 12z equals 16. When we had, what form does it kind of look like that's in? Kind of looks like standard form of a line, but is that a line?
No.
No, that's a collection of points in 3 space, in 3-dimensional space. Anybody want to guess, what would you call a line in 3 space? What's the equivalent structure? What's this table?
3D.
The surface of this table, what would you call that? You call it a, begins with a P? A plane. This is the equation for a plane. What are the 3 methods we have for solving systems of 2 by 2, 2 equations and 2 variables? We have substitution. What else do we have? Elimination. We have graphing. One of those methods we're not going to do in 3 dimensions. Which one do you think we're not going to do? Here's why. These are the situations you could have. 3 planes, they could intersect to form a point. 3 planes could intersect to form a line. All 3 planes could be the same, and then they're one plane. They can be parallel, though no points in common. How many points do all 3 planes intersect here?
None.
None. 2 of them do, but do all 3 ever intersect?
No.
No. What about here? Oh, not all of them intersect at the same place. Or you could have 2 that are the same and 1 that are different. The challenge here is that graphing planes is not super easy. What about graphing planes accurately? No. Graphing planes is really, really hard, especially since you were graphing 2 lines. And how accurate were those 2 lines? Even if you took your time. Sometimes they're not that accurate, right? Even if you spend a long time, you have to sit there and find out what point is that. When you have a point in 3 space, you need horizontal position, vertical position, and then depth. Estimating where a point is in space just by looking at it, is that hard or easy? What do you think? It's pretty hard. You never really do that. So what are the 2 methods we're going to focus on? Substitution and elimination. Substitution and elimination. These are the steps that they list out. They give you cases, and then they give you these steps. What I want you to do, ignore these for now. I think reading these steps makes it harder than it is. We're going to attack things that look like this. Again, what's the only thing that's new about that? There's 3 equations and 3 variables. If I presented you with 2 equations and 2 variables, with 5 being happy and 0 being totally sad, what would you feel if there was 2 equations and 2 variables? What would you feel? 2 equations and 2 variables. Something normalish looking with non-nasty numbers. 4 or 5, you're pretty confident of it. What our work is going to be is turning this into a 2 by 2 system. We're going to take this and turn it into 2 by 2 land. If we're in 2 by 2 land, are we happy?
Yeah.
Or are we as happy as we can be with 2 by 2 systems? Yeah. So what do we need to learn how to do? We need to learn how to take, what is that? A 3 by 3 system and turn it into a
2 by 2 system.
As long as we can turn it into a 2 by 2 system, do you have lots of tools available to you to attack 2 by 2 systems? Yes. We're turning this into a 2 by 2 system. What was the first thing we did with substitution? What was the first thing? We're going to do the exact same thing. When you isolate, you have to pick one variable in one of the equations. It can be any one you want. Which variable do you want to pick to isolate?
Z.
You want to do Z? In which equation?
Well,
We'll call this one. Did you say I'm Canadian? Is that what you said? Okay. We're gonna pick. Okay. You want to pick a variable z, but in which equation? The first one. I like that. Why did you pick that one?
Because it's all by itself.
It's all by itself. It's positive. There's no coefficient in front of it other than 1. So if we want to isolate z right here, what would z be? Can someone tell me what z would be? 2 minus what? Minus 8. Well, you can just get rid of the parentheses there. And in general, it's really helpful if you write these variables in alphabetical order. It's helpful. Well, so we isolated. Oh, we've done isolation before. What was that second step we liked to do when we did substitution? We used to plug in. We used to like to sub. Here's the change. Where are we going to plug this in? Where do you think we're going to plug this in? If we have equation 1, equation 2, and equation 3, where do you want to plug it in? Yeah, and no, we used 1 already. If we plug that back in, into both of them. If we plug them into z here and z here, what do we end up with? X plus, so this is the new line 2, minus 3 times what?
2 minus
Equals negative 14. And then you end up with 2x minus 3y plus 2 times 2 minus. Can you tell me, if I just gave you this right here, what is this? What is that? How many equations is it?
That's just like a
Two variables, how many equations? This is a 2 by 2 system. Do we know how to work with 2 by 2 systems? We have to clean this up and then do the method, but do we fundamentally have what we're comfortable with? Was this a lot of work or a little? It wasn't that much. Be careful though. If you substitute wrong, if you isolate wrong, what happens when you create this right here? It becomes crushingly not fun. Yes.
Okay, so but like after we do everything.
Good. Okay, good.
Y, and then we have to go back.
Correct. Exactly. So that was great. So the only thing we're adding in here is we know how to work with 2 by 2 systems. What did we just learn how to do? Turn into. And once we get the 2 by 2 system, find third value. So let's say we do the work here. Let's just pick numbers. Let's say the answer was x was 1 and y was 2. That's not correct, but let's say it was x was 1 and y was 2. What would you do? Anywhere you want, and you would get z.
But like, how would we write that?
How would you write it? You want to guess? I bet your guess is going to be correct. X. Correct. That's the form your answer takes. So, see all these steps that the book presents you with? Ignore them for now. If you want to go back and look at them, that's fine. I find this to be an overwhelming amount of text. You're not going to memorize this. I don't think it's super helpful. What you need to remember is all you're doing is turning a 3 by 3 system into a 2 by 2 system. Yes? No. You could absolutely. Absolutely. So let's pick a different one. So let's say this one right here. This one right here. Well, if we're going to solve this 3 by 3 system, we need to first turn it into a 2 by 2. Which variable in which line? So x, y, or z, or 1, 2, or 3?
X2.
I like x3. Why do you like x3?
2y and 4
Positives. If you chose this one, you'd have a negative on the other side. It's a little tiny bit of difference. It can help. So if it was me, I would put x here. I would move these two to the other side, and then you'd have x equals 5, negative 5, plus this, plus that. So after we isolated, what was that next word? Substitute. So do this for me. Isolate x right now. Do that right now. Isolate x for me. Wait, hold on. You only need to isolate once. You only need to isolate once. You only need to isolate once. So what was, on this one, what was x equal to? 2y equals minus 5. You then take this and you plug it in here, and you plug it in there.
Right.
Okay, so now when you do that, you want to plug it into the second one. Let's say we did the second one. It'd be 2y plus 4z minus 5 plus 4y minus 2z is equal to 9. That would be your new line 2. Okay, good. So then you would want to get your new line 1. It'd be 2 times, was it 4y? No, 2y, right? 2y plus 4z minus 5 minus 5y plus 3z equals negative 1. How many equations is that? 2. How many variables is that? Do we have lots of different ways to solve that? Absolutely.